So we've had a few sessions already. We had an oral session on this topic, a poster session, as well as a keynote and discussion panel yesterday on this session. It is something that we've been working on for more than 2 years, so it's been rather intense. So I'll try and keep it into a few slides, what we've done in a few minutes, to just take you through all the steps that we followed in order to prepare this strategy for sustaining the IMS into the future. So basically, this is the goal of the strategy, now that we've developed it, is to ensure a high-quality, authenticated, and secure detection network and an assured flow of data. So that was really our goal with this strategy that we've developed. And so we were given this task, where to start. We looked at a variety of sources of information in order to start collecting, putting it all together and figuring out what to do with it as we go further. So we looked at internally, sources within the PTS, the various databases that we have. We also consulted outside the PTS, station operators, network managers, manufacturers, etc. Then we put it all together and started working on that information that we collected. I think you've seen a similar slide yesterday during the keynote. And what we're trying to show here is really that the first few years after the signing of the treaty, we were really actively engaged in just installing stations, and that's what you can see in those green bars, the green bars there. There's this dense installation activity of installing the stations, and then the red bars are really indications of revalidations or where we've recapitalized the stations. And as you can see, it isn't a mirror image that we would expect. So that's basically what we saw. We noticed that there's this most of our stations are installed in the early 2000s, and we need to start thinking, when are we going to have to recapitalize? We also identified the life cycle of a station. We try to break it down into phases, into stages, with the first stage being your site surveys, your installation, and then certification. And that's basically when the clock starts ticking. Then your station lasts most of its lifetime in the operation and maintenance phase, where it is just your normal preventative maintenance, corrective maintenance, everyday thing. It starts to then get to a stage where you need to start doing upgrades and replacements, and then eventually we will get to a stage where the station needs an overhaul, a total recapitalization. We do that, and then the clock starts ticking once again. So then it basically goes back to the green bars, the green section once again. So once we had that life cycle of a station in mind, we could then look at each of the technologies and trying to determine now where those technologies are in each of the stations and those technologies, where are they in their life cycle? And as you can see, we have quite a few in the red zone. So this then caused us to start looking further, and obviously it put a bit of pressure on us. So what we tried to do then, since a station is made up of many different sections or components that can have different life spans, we decided to then, where possible, break up a station into what we call subsystems, depending on the technology. Once we did this, we can then work out through the consultation with station operators and manufacturers. We also look at obsolescence and failure analysis. We can then determine for each of those subsystems the sort of lifespan we can expect. Once we know that, then we can know how long where everything is and how long we can expect a certain station to last. So one of the things that we did not consider for the IMS sustainment was for the stations to run to failure. That was not what we wanted to consider, because then you start to have downtime, and then of course we cannot stick to our mandate. The only technology where we could considered that we could run to failure would be the underwater hydroacoustics, because for two main reasons. The one reason was that from experience and from the manufacturers, we've noticed that they're pretty hardy, they're very robust, and they tend to have a very long lifespan. So we could probably, and the manufacturers in fact said that they could last a lot longer than what we anticipated. We originally anticipated 35 years. And then the second one was the fact that it's a bit more costly. Anything to do with marine, unfortunately, is pretty costly. So that is the only technology where we considered we could run to failure. The rest of the technologies, the risk was just too high. Then what we did as well, we tried to identify what would be the risk in delaying sustainment actions. Of course, we will then start to get more and more equipment becoming obsolete. The spare parts, we would start to run out. The manufacturers would no longer make those spare parts. And then, of course, you just would then start to lose coverage. We've been shown that we have really good coverage. We've managed to monitor all the explosions at DPRK, so we would then start to lose that data coverage. And of course, another big threat that we identified was the authentication of data. It would then become compromised, so then we wouldn't have that, be able to verify information. So what we also did is we identified some main risks and then try to find a mitigation strategies of all these risks that we identified. And the one clear mitigation strategy that came out for most of these is that we would then start to have to rely more and more on national means and voluntary contributions. It would then start to be, we need to start leaning quite heavily on those. So for instance, for the IDC products, we won't be able to give such good accuracy due to the sparseness of the network, and as well we would start to miss events as well. When it comes to the stations themselves, we would have limited capability to implement any plans, so it would be more of a reactive strategies, reactive plans. There would be, of course, increased subsystem failure, leading to even bigger gaps of failures, where you would actually maybe even get to a point where you have a group of stations all failing at the same time in a particular area, so you would have a big hole in the coverage. So I'm just jumping around here, sorry. I see Mario was trying to figure out where I was. So also we would have, one of the things that came up as well is the specialized suppliers. Some of our technologies, as you can imagine, we have suppliers that are quite specialized for us. And now if we were to start not ordering and not being able to support them, we would then start to lose those specialized suppliers. And then, of course, trying to maintain the obsolete equipment. Another interesting fact was the loss of expert knowledge for engineering and development. The idea being there that we'd be relying too much on just quick fixes and maintaining the stations and not being able to actually try and design more robust stations. So basically the idea is that we would constantly be playing catch up, and it would just be a downward spiral from there. So our conclusion for that, we've put this technical strategy together. It was shared with Working Group B, and they approved it. They acknowledged that it was technically sound, our methodology. So now we've got cost estimations from the subsystems that we identified, the ages and when they need to be replaced. We then put in, obviously, price tags on that. So now we have a cost estimation in order to address the technical needs. And now we just need to then look into that, into the funding itself. So thank you very much.
Thank you. Do we have any questions from the floor? Go ahead, if you could go to a microphone, that would be helpful. I also have some in the chat, so I'll be the one in the chat while she's going to a microphone. So this question is, why, in your view, does the treaty not mention sustainment of the IMS? It refers only to maintenance, operation, and installation of the IMS and related costs. Was that an overlook by the experts who participated in the elaboration of the treaty? Do you think that when we complete the current sustainment cycle, it will be high time to launch a new one? I think that must mean like an edit to the operational manual or treaty.
I think, again, it depends on how you define the maintenance aspect. So if you think sustainment basically is maintenance, right? So we are maintaining the network. So I think the treaty means that we need to maintain the network going into the future. So I don't see that it being a gap in the treaty at all. So I think it just means we are just using it. I think we're trying to now distinguish it more from the normal operation and maintenance that we usually do, as opposed to more of a long-term sustainment, how we foresee it going into the future.
And do we have, yes, go ahead.
Thank you very much, Michelle, for your presentation. You laid down some very good points. And I do remember that last time in China, we raised some of a few points on the stations coverage and some software issues. It's not directly related to that one, but I think it's kind of related. First one is station coverage. I think many colleagues and some other people say that the gap of the data coverage is much higher. So when you're talking about robust stations, where the CTBT or where you are right now to just kind of like losing faith from those people who are using the data, the IMS data, and because, for example, I'm taking an example, a clear example. When you check the data from the station, and you realize that you have so many gap of bunches of data of magnitude that you cannot localize or cannot work with them. So this is depend on the structure of the IMS stations, or what missing in the coverage in the stations, basically. When saying about building robust IMS stations.
Right, so when we talk about robust IMS stations, we're referring to stations that can firstly last for a long time. It can then also withstand the normal environmental conditions that station is located in. Also, for instance, we think of if there's a problem with vandalism, we try to make the station more robust in that respect as well, try to come up with ideas to protect the station more. So that's what we try, when we talk about robust, that is what we're talking about.
And sorry, what does the PTS think about upgrading some functionalities within the station, depend on having, for example, let's say coverage of magnitude of data from 1 to up? Because some of the magnitude are not located within the IMS. And I'm talking about that because our local network, we can find smaller magnitude. I mean, I don't know the coverage of the IMS, but I think this is a question that we should raise and try to see. That's the final one idea is that maybe it's good related to the station issues, the softwares also, the GeoTool, because people start raising issues about the GeoTool software. I don't know if it's linked directly to what, but
We'll
sorry
talk
for
about
that.
GeoTool later.
Yeah? Okay, thank you.
Michelle, could I ask you one more question? You had that list of risks, that really great list of risks. Is there a risk that you think is routinely underestimated in this conversation?
Routinely underestimated.
Or maybe, since it's been a 2-year process, I should say, is there one that at the beginning of the process was not so well recognized, but now is?
I think one of the things that we realized there could be gaps is maybe, and that's something that we try to address also through the station operators, is that we may not know what's actually on the ground there. So there are some stations, obviously, that when it comes to especially your auxiliary stations, but there are some stations that we don't always have that intimate knowledge about what the infrastructure could be like and things like that. So there were, when we first started on that, there were some gaps that we identified that we probably need to just, through questionnaires or through interactions with the station operators, improve our knowledge on. Yeah.
Okay. So we have one more question, please. It's a hot topic.
Ilya Drika, STI. The question about dual-purpose stations, for example, when you have USGS and CTVTO, when USGS decides to change the hardware, this hardware is no longer supports CTVTO standards. What is your plan with those stations?
Mm-hmm. Yes, we'd like to collaborate, obviously, with that. It's something that we would like to engage with station operators to talk about it, because we do have a type of what we call approved equipment that we would prefer, that could send the data, for instance, or the sending the data to us, the authentication, very, very important for the PTS. So we would encourage open discussions to try and resolve the different options. That I know that some station operators would prefer others, certain equipment over others, but that's something that we would really like to try and work together with the station operators and see how we can resolve that, so we can, because it is important, obviously, for us to have that. Yeah.
Okay, so
I think we're going to have to move on, Brian.
But I leave you with one last one within the sustainment and enhancement. How about started having temperature recording and the status bits for the state of the waveform technologies?
Well, yes, any kind of health monitoring, I think, is very important. That is also something that we would like to investigate. We need to see how we can then do more preemptive maintenance and anticipate when we need to work on a station. So that is indeed, and I think that's also what Shioli mentioned yesterday as well. That's something that we would like to start looking into more and more. Yeah.
Thank you.
Thank you, Michelle.